Let's study effectively with Miss ICT Skill Builder.
Look at this massive string of binary data. Imagine trying to type this out perfectly, ones and zeros, without making a single mistake. It is incredibly easy to slip up. But what if we could squish it down into just 6 characters? That shorter code is written in hexadecimal. It is a base 16 system built as a shortcut. It uses digits 0 through 9 and letters A through F for values up to 15. The central rule: every hex digit represents exactly 4 binary bits, called a nibble. Let's test this. What is the numerical value of E? 14. Hexadecimal doesn't change the data your computer processes. At the machine level, it is all still purely ones and zeros. Hex is simply a human-readable wrapper that makes huge walls of data much easier for us to read, write, and remember. This document shows exactly how we perform that conversion. To turn binary into hex, you slice the binary string into groups of 4. You must strictly start from the far right and work your way to the left. You will often run into a situation where the final group on the left is short of 4 bits. When that happens, you pad the front with leading zeros to complete that final nibble. Pause the video and try this one yourself. Convert the binary sequence 101011110001 into hexadecimal. You should get AF1. This next table shows the reverse process. Moving from hex to binary is just unpacking the box. You take each letter or number and expand it back into its specific 4-bit binary sequence. Because 16 is a power of 2, these base conversions don't require complex arithmetic. They are purely visual grouping exercises. You are just swapping blocks back and forth. Now look at this example showing how we convert hexadecimal into standard human numbers, which we call Denary. We set up place value columns, specifically multiplying by 256, 16, and 1. Notice what happens with the letters. Before you can multiply, you have to swap any letter back to its Denary value. Here, the A becomes a 10 before we multiply it by 1. Take a second to practice this. What is the hex value 1A in Denary? 1 times 16 is 16, plus A, which is 10, gives us 26. Going the other way, from Denary back to hexadecimal, requires division. We divide our Denary number by 16 to find out how many times it fits. Then we look closely at the remainder. That remainder maps directly into the base 16 toolkit. It becomes your hexadecimal digit. Let's try one more calculation. Convert 125 to hexadecimal. 125 divided by 16 goes in 7 times, with a remainder of 13. Since 13 is D, our final answer is 7D. Unlike the neat visual chunking we did with binary, interacting with human numbers requires this mathematical division because our base 10 system and the computer's base 16 system do not cleanly align. Look closely at the bottom of this crash screen. System error codes are output in hex to quickly point developers to the specific memory location where a failure happened. You will also see this in networking hardware. This physical network interface card uses a MAC address, a 48-bit hex sequence that uniquely identifies this specific device on a network. Hexadecimal is also how the modern internet routes traffic. To ensure we don't run out of addresses for billions of connected devices, the internet relies on 128-bit IPv6 addresses, all formatted in hex. This color selection tool shows how web developers use hex codes in HTML. A 6-character string dictates the exact mix of red, green, and blue pixels needed to display a specific color on screen. Whether it is hardware identification, network routing, or web design, hexadecimal acts as the universal shorthand for device configuration. Let's lock this in right now. You have 15 seconds to tackle 3 rapid-fire conversions across binary, hex, and denary. Go! Check your answers against this visual cheat sheet. It contains the nibble rule, your place values, and the real-world applications. Take a screenshot of this right now for your exam revision. Before you go, here is one final test. Convert the hex number A7 into both its binary and denary formats. Prove you have mastered the translation layer between humans and computers by dropping your answers in the comments below.
Thanks for watching. If this helped you clear up the concept, hit that like button and share it with a friend who might be struggling with it too. Let's build those skills together.